You understand the theory. You know how neural networks function. You can write the code. And your model runs perfectly in the safety of your computer. But deploying that model into a live business environment is a different challenge. To bridge the gap between a prototype and a production-ready system, you need a structured approach. Today, we are mapping out a systematic 5-step AI project blueprint from start to finish. To show you exactly how this works, we will run a master template alongside our blueprint, building a financial fraud detection system. Before we begin, grab a blank document or use the downloadable PDF below to map out your own project alongside this case study. When your model hits the friction of live data and operational demands, a structured blueprint is the only way to prevent a promising project from collapsing under real-world complexities. Step 1 is defining the problem. Your goal here is to write a specific business objective, not name a technology. Building a neural network is a method, not a target. For our case study, the objective is detecting fraudulent transactions in real time. With a clear operational goal set, we move to step 2, data collection and preparation. Here, map out your data sources and specific cleaning requirements. In fraud detection, you will immediately hit a massive friction point during preparation, severe class imbalance. If 99% of transactions are normal, a model achieves 99% accuracy by always guessing normal, failing its actual objective. To fix this, Smote generates synthetic examples of rare fraudulent transactions, multiplying the minority class until reaching mathematical equilibrium. If you skip this data balancing step, you guarantee a model that is technically highly accurate, but operationally useless. Step 3 is model design and development. The core rule here is to start with a simple prototype before escalating to a complex architecture. For our system, we backtenant a simple logistic regression model first. This establishes a baseline performance floor to measure against. From there, we escalate. As this diagram of a deep neural network shows, the multiple hidden layers provide the structural complexity required to capture the highly complex, nonlinear patterns of modern fraud. But algorithms require the right inputs to function. You must use feature engineering to isolate attributes that matter, like extracting a user's login frequency or tracking unusual geographical locations. This leads directly to step 4, evaluation and validation. As we saw earlier, evaluating your model based on standard accuracy is a critical mistake. Let's look at a confusion matrix. A false positive might mildly inconvenience a customer, but a false negative carries a catastrophic financial cost. To account for this, we document specific evaluation metrics, precision, recall, and F1 score, to minimize those costly misses. Selecting the correct evaluation metric is the exact mechanism that aligns your machine learning algorithm with actual business risk. Finally, we reach step 5, deployment and production. A successful model cannot live on a local laptop. It must be engineered for enterprise integration. We start by containerizing the model. Locking the algorithm and its dependencies in an isolated environment ensures it scales safely under high volume. Next, we wrap that container in an API, creating a bridge for the model to communicate with the real-time transaction pipeline. Because live environments change and cybercriminals evolve tactics, you must establish continuous post-deployment monitoring to catch concept drift early. Hitting deploy is not the finish line of an AI project. It is simply the beginning of the model's operational lifecycle. Look at our fully populated 5-step blueprint. Every phase is accounted for, from the initial problem statement down to the final deployment strategy. By methodically documenting this process, you stop building isolated models and start architecting comprehensive industry solutions. Now it's your turn. Take this framework, acquire a starter dataset, and begin building your prototype. You can find the link to download the blank blueprint template, along with a list of beginner project ideas, in the description below. True AI expertise is not measured by understanding algorithms in theory. It is measured by your ability to deploy them to solve problems in reality.